Welcome to another in the series of demonstrations designed to get you quickly up to speed with what's new in NX-CAM. This video will demonstrate how you can perform hybrid manufacturing by combining an additive metal deposition process with the traditional NC machining subtractive process to produce highly complex finished parts using a single machine tool setup. In this example, we'll use hybrid manufacturing to create a rotary part. Note that you will need to have an appropriate license to perform hybrid manufacturing. Let's take a look at the objects required to perform hybrid manufacturing. The initial workpiece is the plate or base that the material will be deposited onto and is clamped into place as part of the setup. The additive raw material is what will be built through the additive operations. It will be selected as the blank geometry for the subtractive operations. The finished part is the final outcome of the hybrid manufacturing process and is the product of both additive and subtractive operations. We'll begin by creating the setup. Select File New. Select the Additive Manufacturing tab. Select the template. Click OK. The next few steps will remove some of the unnecessary clutter from the graphics window. In the Assembly Navigator, select the checkboxes so that only the initial workpiece, raw material, and finished part are displayed. Next, we'll create an associative copy of the initial workpiece, the additive raw material, and the finished part bodies. These associative copies are the bodies we'll decompose into additive features and then use for the additive and subtractive operations. Select the Applications tab and select Assemblies in the ribbon bar if it's not already turned on. Select the Part Navigator tab in the Resource bar. Select Menu, Insert, Associative Copy, Wave Geometry Linker. Select the raw material. Click Apply. Select the finished part body. Click Apply. Select the initial workpiece. Click OK. Notice the three wave-linked bodies in the Part Navigator. Rename the three bodies. For now, we will only need to work with the additive raw material linked body, so we'll hide the unnecessary geometry. In the Assembly Navigator, select the Rotary Assembly checkboxes to hide the objects. Select the Part Navigator tab in the Resource bar. Right-click Finished Part and select Hide. Right-click Initial Workpiece and select Hide. Only the additive raw material linked body should be displayed. Decomposition allows you to divide raw material into individual additive features by extracting bodies. Each additive operation requires a complete body or set of bodies. You may decompose explicitly or automatically. Explicit decomposition allows you to decompose a specific volume of raw material by specifying a plane that terminates the decomposition at an explicitly defined location. Select the Additive Tools tab in the ribbon. Select Decompose. For Select Part in the Decompose Part dialog box, select the displayed additive raw material body. For Select Face, select the face on the bottom of the additive raw material as the starting face. Type 10 in the Decomposition Tolerance box. The decomposition tolerance is the increment that the processor uses to step along the part. Larger values result in faster performance, but the value should not be so large that small features will be missed. Select Stop at Plane from the Stop Condition list. This option allows you to be very specific about the portion of the body you wish to decompose. Select the edge of the additive raw material just above the blades. Click OK. The portion of the body between the selected face and the plane has been decomposed into additive features. These new features can be used to create an additive operation. Next, we'll specify the geometry needed for the additive operations. The base plate is the body onto which the additive material will be initially deposited, and the raw material represents a slightly oversized version of the finished part. Right-click Initial Workpiece and select Show. Select the Operation Navigator tab in the resource bar. In the Geometry view, double-click Hybrid Geometry to edit the object. Click Specify Initial Workpiece. The initial workpiece is the plate or base that the additive material will be initially deposited onto. Select the base as the initial workpiece. Click OK. Click Specify Additive Material. Select the 7 extracted bodies. Click OK. Click OK in the Hybrid Geometry dialog box. Now we'll specify the part and blank geometry for the machining or subtractive operations. Select the Part Navigator tab in the resource bar. Right-click Finished Part and select Show so that the 7 extracted features, the initial workpiece, and the finished part are all displayed. Select the Operation Navigator tab in the resource bar. Double-click Workpiece Milling to edit the object. Click Specify Part. Select the solid gray body of the finished part as the part geometry. Click OK in the Part Geometry dialog box. Click Specify Blank. Select the 7 extracted bodies as the blank geometry. Click OK in the Blank Geometry dialog box. Click OK in the Workpiece Milling dialog box. The first additive operation will use planar slicing and a fixed tool axis to form the cylindrical body. Before creating the first additive operation, we'll hide the finished part and the initial workpiece. This will allow us to see the material deposition as the initial workpiece is created. Select the Part Navigator tab and hide all of the objects except Extracted Body 26. Select the Home tab. Click Create Operation. Select Additive from the type list. Select Planar Additive Spiral Inward and Outward as the operation subtype. This operation subtype deposits material in successive planar layers using an inward or outward spiral pattern. Specify the parent items. Click OK. Click Specify Additive Feature. Select the body you wish the additive feature operation to create. Click OK. Type 3 in the layer thickness box. This unusually large value will allow you to see the individual layers more clearly. Realistically, the layer thickness would be much smaller than 3 millimeters. Click Generate. Now we can visualize the additive material deposit. Select Verify. Select the 3D Dynamic tab. Clear the Check for IPW Collisions checkbox. This will improve processing time. Set the animation speed and click Play. Click OK to complete the visualization. Click OK to complete the operation. Next, we'll create an additive operation that uses profile slicing and a variable tool axis to form one of the blades. Right-click and select Show for extracted body 32. Click Create Operation. Select Rotary Additive Spiral Inward and Outward as the operation subtype. This operation subtype uses a variable axis output to deposit material in successive rotary layers using an inward or outward spiral pattern on a contoured foundation face. Use the same parent items as specified in the previous operations and click OK. Select Specify Additive Feature. Select the blade as the body you wish the additive feature operation to create. Click OK. We'll specify the cylindrical face as the foundation face. Click Specify Foundation Face. Select the outside face of the cylinder. Click OK. Be sure axis of rotation is set to +ZM. Select Away from Axis Rotation as the output axis. Type 50% tool in the minimum path overlap box. This is the minimum amount adjacent paths are allowed to overlap. A larger value permits a greater overlap, allowing deposition to occur within a narrower area. Click Generate. Now we can visualize the additive material deposit. Click Verify. Click Play. Click OK to complete the visualization. Click OK to complete the operation. Next, we'll instance the blade operation to create the remaining blades. Select the Operation Navigator tab. In the Program Order view of the Operation Navigator, right-click Rotary Additive Spiral and choose Object, Transform. Click Specify Point. Click OK to accept the XYZ coordinates. Type 360 divided by 5 in the angle box. Type 4 in the number of instances box. Click OK. 4 instanced operations have been created. Lastly, we'll create an additive operation that forms the top of the part using planar slicing and a variable tool axis that follows the contours of the additive feature when forming the inner and outer walls. A variable tool axis will form smooth walls and prevent depositing material in error. Select the Part Navigator tab. Right-click and select Show for all of the extracted bodies. Click Create Operation. Select Planar Additive Spiral Inward and Outward as the operation subtype. Click OK. Click Specify Additive Feature. Select the body you wish the additive feature operation to create. Click OK. In the Slicing and Output Axis section of the dialog box, select Automatic from the Output Axis list. Type 2 in the Layer Thickness box. Click Generate. Click OK to complete the operation. Now we'll visualize the additive material deposit. Select the Operation Navigator tab. In the Operation Navigator, select Program. Select Verify Toolpath. Click Play. Click OK to complete the visualization. Next, we'll begin the process of creating subtractive operations. We'll define the hub, shroud, blade, and blade blend geometry required to machine the part and then finish the blades and hub. Select the Part Navigator. Show only the finished part. Click Create Geometry. Select Mill Multi-Blade from the type list. Click Multi-Blade Geometry. Select Workpiece Milling from the Geometry list. Click OK. Click Specify Hub. Select the face defining the hub. Click OK. Click Specify Shroud. Select the face on the edge of the blade. Click OK. Click Specify Blade. Select the four sides of the blade. Click OK. Select Specify Blade Blend. Select the four faces defining the blend of the blade. Click OK. Type 5 in the Total Number of Blades box. Click OK. Now we'll create a machining operation that finishes the blades. Click Create Operation. Select Blade Finish. Specify the parent items and click OK. Click Cut Levels. Be sure Interpolate from Shroud to Hub has been selected from the Depth Mode list. Select Scallop from the Depth Per Cut list. Type 0.05 in the Scallop Height box. Click OK. Click Blade Finish. Select All Sides from the Sides to Cut list. Click OK. Click Generate. Click OK to complete the operation. Lastly, we'll create an operation that finishes the hub. Select Create Operation. Select Hub Finish. Click OK. Click Hub Finish. Select Along Part Axis from the Blade Edge list. Specify the distance and the radial extension. Select Zigzag with Lifts from the Cut Pattern list. Click OK. Click Generate. Click OK to complete the operation. The Operation Navigator shows both additive and subtractive operations. Now we can visualize the hybrid program. Select the Part Navigator. Right-click the finished part and select Hide. Select the Operation Navigator. In the Program Order view, select Program. Click Verify Toolpath. Click Play. The remaining machining operations would include instancing the hub finishing operation as we did with blade finishing and then finishing the top of the part. This concludes the demonstration of how you can perform hybrid manufacturing by combining additive metal deposition with CNC machining. Thank you.